Hello, welcome to all. Today we discuss design and simulation of three-phase transformer. Okay, so what is a three-phase transformer? First, we design three-phase transformer. The structure is like that. This is your rectangle, and we draw two more rectangle, so it's look like a three-phase transformer. This is your first limb, second limb, and third limb, and here we placed low voltage winding. Here we placed low voltage winding. After that we placed a high voltage winding. Okay, with the help of rectangles, here we create a low voltage and high voltage winding. This is your low voltage winding, and this is your high voltage winding. Okay, so let's start the practical session. Okay, so what is the first step? First step is open ANSYS electronic desktop and wait. This is your ANSYS electronic desktop is open, and here we will discuss how to model a three-phase transformer in both Maxwell 2D and 3D. After that, and here we using eddy current solver and transient solver, and we can perform the following tasks like create a three-phase transformer in 2D model in eddy current solver and analyze the result. After that, create a three-phase transformer 2D model in transient solver and analyze the result. Here we use a no load and full load for both. Okay, so start the session. Okay, so what is the first step? Here first model in which we use no load analysis. First, go to Maxwell's and open Maxwell's, click on Maxwell 2D and wait. This is your modular window. This is your project manager, and this is your history tree. Okay, so next step is set a solution type. For set a solution type, go to Maxwell's 2D and click on solution type. Here our geometrical mode is Cartesian XY, but solver is eddy current. Choose eddy current solver and make it OK. After that, the next step is set a model unit. Go to modular and click on units. Select unit is make it OK. After that, next part is create model. In create model, we start with core. First we draw a core with the help of rectangle. Go to draw and choose a rectangle. Write down first coordinates value is x is minus 119, and y is minus 94, and z is 0, because our plane is xy. Click on OK. Put the value of dx is 238, and dy is 188, and dz is 0. Make it OK. Here we increase the scale up to 200 mm. Our first rectangle is proper visible. Now next step is go to history tree. This is your history tree. Double click on rectangle 1, change the name. Name is core. And select material. Click on material, edit, and click on show all libraries. Write down here M15_29G. Select M15_29G and change the color of code. Okay, this is our rectangle 1. After that, here we create a window. With the help of rectangles. Again, go to draw, choose rectangle, put the coordinates. X is -81 and y is -56, z0. Click on OK. Here OK means press enter key. Okay, next put the value of dx is 62 and dy is 112 and dz is 0. Press enter key. This second rectangle. Next step is go to history tree and select rectangle 1 from history tree and go to edit and search duplicate. Click on mirror. Okay, so here we create a mirror of first rectangle. So step is how to create a second rectangle for same distance. First select the origin with the help of mouse pointer and drag in X direction and double click. This is your rectangle 1_1. Okay, this process is known as duplication of sheet. Okay, next step is here we subtract 2 rectangles from the main rectangles. Okay, so select core, rectangle 1 and rectangle 1_1 from history tree and go to modular, search boolean and click on subtract. In blank part check core is present. In tool parts is rectangle 1 and rectangle 1_1. If here suppose here rectangle 1 is present, select rectangle and place in tool parts. Okay, click on OK. This is your transformer core. And next part is create first coil. For first coil we use another rectangle for creation of coil. Go to draw and choose rectangle. Put the coordinate of rectangle is -31 and y is -48. Z is 0. Press enter key. Dx is 10 and dy is 96. Dy is 96 and dz is 0. Press enter key. This is your first coil. Okay, here we go to history tree and double click on rectangle 2 and change the name. Name is coil and assign material, edit, and search copper. Connectivity of is copper is good. Here we select a copper material and choose color for coil, make it okay. Okay, after the completion of this step, the next step is duplication of coil. For duplication of coil, select coil from history tree, select coil from history tree and go to edit and search duplicate, click on along line. Here put the coordinate x0, y0, z0, press enter key. Here enter the vector increments. Vector increments is -11 mm and dy0 and dz is 0. Press enter key. Okay, here insert 2, click on OK. After the completion of this step, next step is this is your lower voltage winding, this is your higher voltage winding. Okay, after that we create another 2 seat in this side. Okay, we complete the first lower voltage winding, then we complete a higher voltage winding. Okay, so similarly here we draw a 2 rectangle in this side also. Okay, so first select first select 2 seats from history tree, this coil and coil 1, coil and coil underscore 1, and go to edit, duplicate and click on mirror. Okay, and select the origin with the help of mouse pointer, single hit and double click on, scroll mouse pointer in X direction and double click. This is your lower voltage coil and higher voltage coil. Okay, so and this one is complete lower voltage winding, and this one is complete higher voltage winding. Okay, after the completion of this step, create coils for 2 lateral legs. Select 4 seats from history tree, coil underscore 1, coil underscore 1 underscore 1 and coil underscore 2, and go to edit and duplicate, select duplicate along line, put the coordinates x is 0, y 0 and z is 0, press enter key. Here vector increments is for first, write down value is plus 100, dy 0 and dz is 0, press enter key, insert 2. Okay, after the completion of this step, repeat the same step. Select 4 seats from history tree, 1 2 3 4 and go to okay, manually select 4 seats from history tree. Okay, coil underscore 1, coil underscore 1 underscore 1 coil underscore 2 4 seats. Don't select these seats. Okay, and again go to edit, duplicate a long line. So here write down value x, y, z, all values are 0, and write down value is dx value is minus 100. In previous case we put the value of dx is 100, but in this case we put the value of dx is minus 100 and rest dy and dz is 0. Press enter key. Okay, insert to make it okay. Okay, this is your transformer coil. Okay, after the completion of this step, next step is assign excitation to the coil. Okay, and next step is assign excitation to the coil. So select first all lower voltage winding. This is your lower voltage winding, lower voltage coil, lower voltage coil, lower voltage coil, and lower voltage coil, lower voltage coil, and lower voltage coil. Select all lower voltage coil from your history tree. Okay, so you can directly select like directly select or select by your history tree like that. Okay, but it's take a like that, and 2. Okay, and then and the next 3 and 4. So this is all lower voltage coils are selected here, and right click on any coil and search excitation and click on coil. Okay, here number of conductor is 100 for lower voltage coil. Don't change the polarity here, we can change polarity manually later. Click on OK. After the completion of this step, repeat the same step. Select all higher voltage coil from your history tree, or directly you can choose on modular window with the help of control key. Here we select all higher voltage coil. After that, again right click on any coil and search excitation, assign excitation to the coil. Here number of conductor or higher voltage winding is 400. Don't change the polarity here, and click on OK. After the completion of this step, next step is change the polarity. Okay, here here we marked this is your right side and this is your left side. Okay, so here right side of coil select polarity is positive and left side is negative. Okay, assign here for both coils is positive, and for negative, positive, negative, positive and negative. Okay, go to project manager. This is your project manager. Increase the length of this window and explore excitations. This is your first coil. So here we assign polarity is negative. Okay, don't change, select search. This is positive, don't change. This is also positive, don't change. Don't change, change the polarity, negative, change the polarity, negative, don't change the polarity, don't change the polarity, don't change the polarity, change the polarity, negative, change the polarity is negative. Make it okay and verify again. Check this is this coil is negative or not. Negative, correct. This is also negative, correct. Check positive or not. Positive. Check positive. Check it's positive or not. Positive, correct. Check it's negative or not. Negative, correct. Check it's negative or not. It's a negative, correct. Check it's positive or not. This is positive. Check this is positive or not. Positive. Check this is positive or not. Positive. Check this is negative or not. This is negative, correct. Check this is a negative. Okay, correct. So next step is create winding. Go to project manager and right click on excitation, click on add winding. Name is primary underscore A and change the type is voltage, conductor is standard and resistance is 2.2 ohm. Don't change the value of inductance. Voltage is 54 volt. Voltage is 54 volt and phase degree is 0 and number of parallel branches is 1. Okay, click on OK. After that similarly create 2 more windings for primary. Right click on excitation, click on add winding. Here change the name is primary underscore D, voltage, conductor is standard and voltage is 54 volt and resistance value is 2.1 ohm and make it okay. In previous case we put a resistance is 2.2 ohm, so put for primary B is also 2.2 similar resistance. Okay, again go to your project manager, right click on excitations, click on add winding, change the name is primary underscore C, and type is voltage, standard, resistance is 2.2 ohm, and voltage is 54 volt, and here change the phase degree is to 40 for primary C. For primary B, write down it's to 120. Okay, we placed three phase voltage in 120 degree phase shift. This is for primary B 120, for primary C 240 degree, and make it okay. After that we create 3 more windings for secondary. Start, right click on excitations, click on add winding, write down here secondary A. Here type is voltage, conductor standard, and resistance is 160. 1 mega ohm, and inductance value, don't put the inductance value, and don't change the phase. Click on OK. Again right click on excitation, click on add winding, write down here secondary B, and type is voltage, standard, resistance is again 161 and 6 place to 60, and don't change the voltage, and degree is 120 degree, make it okay. Again go to your project manager, right click on excitation, click on add winding, winding is secondary C, click on standard, and here change the type is voltage, and resistance is again, this is here we analysis we use a no load analysis, so resistance value is very high, and inductance, don't put the value of inductance, phase is 240 degree, otherwise leave as it is, make it okay. Okay, this is your 6 windings: primary A, primary B, primary C, secondary A, secondary B, secondary C. Okay, next step is add coil into the windings. Okay, so first start with, this is your primary A, this is your primary A, this is your B, this is your C. Okay, this is your B, this is your C. So this is your primary, this is your primary A, this is your primary B, this is your primary C. Okay, So this winding put into the primary A, this is this put into the primary B, and this winding is put into the primary C. Okay, so manually placed, select coil and right click on it, click on add winding. This is your primary A, click on OK. This is your secondary A, right click on it and click on add to winding. This is your secondary A, make it OK. Okay, these windings are this winding, and this winding are, this is your secondary A, this is your secondary B, and these coils are placed in secondary C. Okay, this is your secondary A, right click on it and click on add winding, select secondary A. This is your secondary B, right click on it, add to winding. This is your secondary B, make it OK. This is your secondary C. Okay, right click on it, add to winding. This is your secondary C, make it OK. This is your secondary B, right click on it, add to winding, secondary B. This is your secondary C, add to winding, click on secondary C. This is your primary A, right click on it, add to winding, select primary A. This is your primary B, right click on it, add to winding, primary, select primary B, and this is your primary C, right click on it, add to winding. This is your primary C. This is your primary B, right click on it, add to winding. This is your primary B, make it OK. This is your primary C, make it OK. Okay, check manually. Okay, this here change, this coil is primary, this coil is primary C. Okay, click on remove from winding. Okay, and right click, add to winding. This is your primary, this is your primary C, make it OK, and check again. This is correct, this is your primary A, primary B is correct, primary C is correct, this is secondary A correct, secondary B correct, and secondary C is correct. Okay, excitation part is completed here. Next step is set eddy effect. For set eddy effect, right click on excitation. This is your excitation. Go to project manager and right click on excitations, click on set eddy effect. Here uncheck all, uncheck all object, scroll and uncheck all object, and check all object are deselected or not, and press OK. Next step is assign boundaries. Next step is define regions or create simulation region. For create simulation region, go to draw and select define region, click on pad or direction similarly checked, and write down the percentage offset value is 20. Press OK. After the completion of this step, next step is assign boundaries. Select seats from history tree and select all object edges. Okay. Select all 4 edges. Go to edit, change the selection mode is edges. Select manually one by one with the help of control key. All edges are selected, and next step is go to Maxwell 2D, search boundaries, assign vector potential, and make it OK. After the completion of this step, next step is set design depth. For design depth, go to Maxwell 2D, search design setting. This is your design setting. Go to model setting tab. Here insert design depth is 39 mm. 39. Design depth is 39 mm. Press OK. After the completion of this step, create analysis setup. For create analysis setup, go to Maxwell 2D and search analysis setup. Click on add solution setup. In general tabs, change the percentage error value is 0.1. Here we reduce the error, and change go to the next solver tab. Change the adaptive frequency is 50 Hz. Change the frequency is 50 Hz and click OK button. Click on OK button, and after that go to Maxwell 2D, apply validation check. Here all parameter is correct. Close this tab. Next step is go to Maxwell 2D and click on go to Maxwell 2D and click on analyze all. This is your transformer. Save the name and wait. Okay, check the message. Okay, normal completion done. Okay, next step is plot message. Okay, go to edit and click on select all and go to Maxwell 2D, search field and select plot message. Click on done. Okay, this is your mesh plot. After the completion of mesh plot, we plot the flux density magnitude. Go to project manager, explore field overlays, and right click on message, click on delete. After that again go to edit, click on select all, go to Maxwell 2D, fields, explore fields, again explore fields, click on B magnitude. Okay, here click on phase degree, change the phase degree is 10 degree, and here select core and click on done. This is your flux density plot on core. After the completion of this step, check the primaries and secondary induced voltages. For this step, go to your project manager and right click on result and click on eddy current report. Create eddy current report, select rectangular plot, and in category X is default, X is check default. Here select winding. First here select induced voltage in secondary A. First select induced voltage primary A. After that select induced voltage secondary A. Induced voltage secondary A. Okay, and click on new report. Okay, here this is voltage for this is 2 voltages plot here. After that plot current. Again go to Maxwell 2D, search results, create eddy current report, click on rectangular plot, and here select category in winding, X is default, and select here primary A, select current primary A, and click on new report. After that load, and in plotted area right click and modify report. In modify report here select imaginary and click on add traces. Okay, this is your imaginary value. Okay, this no load analysis is completed here. After that we move for next experiment. Close this tab. This is your eddy current model for full load analysis. Okay, okay, we right click on this model, copy, and go to project manager, right click and paste. Same model is pasted here. Okay, next step is change the name. Right click and click on rename. is FL, means full load. Change the name, and next step is go to Maxwell 2D. Okay, here we change the resistance value, because this is a no load analysis, so don't change the solution type, change the winding resistance. Okay, change the secondary winding resistance to 100 ohm. Here we reduce the value of resistance, make it okay. Again go to project manager and change the secondary B resistance is 100 ohm, and check for secondary C, double click on secondary C, change the resistance of this winding to 100 ohm, then make it okay. And again go to Maxwell 2D and click on analyze solve. Check the message, normal completion, okay. Close this message window and the next step is plot the value of primary, secondary, induced voltages, and here we use a data table. Okay, and go to Maxwell 2D, and search results, and click on eddy current report, select data table. Here in category winding, select induced voltage primary A, and with the help of control keys select induced voltage primary, secondary A, induced voltage primary A and induced voltage secondary A. Click on new report. This is your induced voltage value. Okay, next step is again go to Maxwell 2D and search results, click on eddy current report, click on data table, and in category close this, and again repeat the same step. Here select imaginary, first select induced voltage primary A and induced voltage secondary A, induced voltage secondary A, and here in function select imaginary, click on new report. Okay, this is your data table 2. Okay, after the completion of this step, next step is calculate current in the winding. Go to Maxwell 2D and in results, in fields, search fields, and click on calculator. Okay, In input quantity, select J. Okay, then to vector, in vector select scalar, is scalar Z, and input, go to again input, then input functions is a face, select face, and make it okay. In general, okay, in general, complex, in general complex, here select at a face, then input geometry, select input is geometry, select surface, in surface select coil, press OK. Select number is 100, and press OK, and scalar, click on integrate, okay. Next step is calculate current in winding. Go to Maxwell 2D, search fields, click on calculator. Okay, next step is go to Maxwell 2D and search field, click on calculator. Okay, here click on clear. If you have any previous expression, it's clear. And next step is in input quantity, select J, select vector, in vector scalar select Z, in input functions, function is face, click on OK. In general, this is your general, in general complex, explore complex, select at a face, then in input click geometry, in geometry select surface, select coil, press OK, then go to scalar, in scalar select integrate, then select number is 100, and in general click on divide and click on add button. Expression name is pri_a, make it okay. Same repeat for second. Current coil 2 and click on done. Next step is go to Maxwell 2D. Here we plot a primary current, primary current A. Go to Maxwell 2D, search results, create an eddy current report, click on rectangular plot. Here in winding, choose primary A, choose primary, select primary current A and click on new report. Okay, this experiment is completed here. After that, next experiment is full load analysis. Close this tab and here next experiment is transient 2D model. In transient 2D model we start analysis on full load analysis. Okay, first again go to this model, right click and copy and paste, press F2, rename. This is your right click and rename full load transient, full load transient, and here check in full load value of your secondary winding resistance, and it is correct. And here this is transient analysis. So go here, change the solver, go to Maxwell 2D, click on solution type, and the solver is transient. Here select transient solver and click on OK. After that, here modify the value of excitations. Go to your project manager and double click on primary underscore A. Here voltage value is 54. Put the multiply symbol, write down sign, and use small bracket, 2, put the multiply symbol, write down pi, put the again multiply symbol, and write down 50, and again put the multiply symbol, write down time, 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 close bracket, and copy and click on done. Change the secondary value also. Okay, same, add here time plus 120 degree, DEG 120 degree plus OK. Again change for secondary, paste, put the plus symbol here, write down time, write down 240 and degree, DEG, and press OK. Okay, and again verify. Okay, after that go to Maxwell 2D and click on analysis setup, add solution setup. Here in general tab, stop time is 40 millisecond and time step is take a 1 millisecond time step, and go to save field tab, choose a linear step, start time is 0, and put this stop time is same 40 millisecond, and time step is 1 millisecond, and click on add to list. This is your time steps, and next step is go to advanced tab. Here in advanced tab, check import message, and in setup link, okay, click on use this project. Source is Maxwell Design Design 1, and setup is last adaptive. Click on simulate source design as needed, and make it click on OK, and next go to solver tab. In solver tab, write down value 1 e minus 6 and press OK, and go to Maxwell 2D, apply validation check, and go to Maxwell 2D and click on analyze all and wait. Okay, check messages is normal completion. Okay, close this message manager, and here first start with plot message. Go to edit and click select all, and go to Maxwell 2D and search fields, click on plot message. Okay, first select time, view, click on set solution context, click on set solution context, select any time, and again go to edit, click on select all, and go to Maxwell 2D, results, fields, plot message, done. This is your mesh plot for transient analysis. And next we plot a flux density. Right click on field overlays in your project manager and delete in yes, and again go to edit, click select all, and go to Maxwell 2D, fields, B, magnitude, select your core, and click on done. This is your flux density plot. After that go to view and click on animate, click on OK. Here we view the flux density plot for 40 millisecond. It's change with time. Here we clearly visible. Okay, close this, and next step is plot primary and secondary current versus time. Same, go to Maxwell 2D, results, create a transient report, select a rectangular plot, select primary A, select current primary A, and click on new report. This is your current. Same step to plot the currents. Okay, this experiment is completed here. Thank you.